Perfect. All right, so welcome to all attendees today. Thanks for everyone that has taken the time to join me on this webinar this morning. We have a really good turnout in numbers and all across Europe, and there's still people currently jumping on. So my name is Brian Fagan, and I'll be your presenter today. Just a little about myself. I've been in the manufacturing industry since 2001 or 2002, in around there, spending 10 years or close to 10 years in a precision engineering company, working with all kinds of manufacturing machinery, but mostly CNC. I spent another 4 years in an R&D startup company, setting up and running a machine shop. After a few years that we got acquired by a well-known multinational company. And I spent another few years managing the CNC department there, but got bogged down in processes and procedures and loads of paperwork, which I wasn't used to at all. So that brought me into joining Cemetery early in 2020. I'm a toolmaker by trade, and I have a degree in manufacturing management, and I'm currently doing a master's in e-learning design and development. I'm from and based in County Limerick, which is located in the southwest of Ireland for people that are joining us from outside of Ireland today. So I will show you whereabout we are. So just to give an idea of where we're located. So that's actually going straight into my housing estate. So that is Limerick, and that's close enough to where Limerick is. So it's about a 15-minute drive into the city for me. What I like to do in my spare time is spend time with my family, travel as much as my annual leave in Cemetery allows me, watch Netflix and drink Guinness, obviously. I love spinning around on my my toy, I suppose. So that is a little bit about me. I'm just going to run a quick poll question just to kind of get an understanding of who we have here, because there is a lot of attendees here today. So just bear with me 1 second and we will run our first poll question. Okay, so I'm just going to leave that question up there for a couple of seconds. So if you could all let me know what's design solution you're currently using at the moment in your organization. So yeah, the idea behind these poll questions is just get an idea of the attendees that are joining us and what other software solutions that people are using out there, and seeing if we can help them out or complement what they're already having, or seeing is there a replacement for what they're currently using. So not sure if anyone is aware, but Autodesk quietly did some rebranding at the start of the year. They made some changes, but mostly nothing that will interfere in your day-to-day business. They also repackaged the extensions, which is a lot more beneficial for the customer because they get a lot more out of it. So let's take a look at the extensions update. So what this slide here shows is previously there was 8 extensions that you could have unlocked within Fusion. Autodesk has merged 8 of them into 5. The main ones that have been upgraded, I suppose, are the simulation, which has now got generative design as part of it. So originally you would have had to buy simulation and generative design, so that's all packaged as one extension. And the second one that has a big change is what was the machining extension has also the nesting and fabrication, and the additive build is part of it now. So they've renamed it, calling it the manufacturing extension. So you're actually getting 3 extensions thrown into all under the manufacturing umbrella. So just to note that if you are interested in investing in a Fusion extension, it's best to reach out to us first so we can ensure that the extension will meet your requirements, along with the adoption, the training, the configuration, and obviously the ongoing support that we do here in Cemetery. Which brings me on to the next point. So this is obviously webinar number 1, all about the machine inside of the manufacturing extension. The next one will be the end of March. So this will be presented by my colleague Cheryl, who's an expert in the simulation field. That is coming up on the 27th of March. So keep an eye out for the registration link on our social media, or feel free to scan the QR code. And I actually have that slide coming up later on or at the end of the webinar as well. So if you do miss the QR code at this point, you can get it towards the end also. Okay, so getting back to the Autodesk's rebranding, they've also decided to do a name change, which may confuse people, maybe. The name Fusion 360 has become so familiar and so commonly heard that we've all become accustomed to hearing and recognizing. So they have now made Fusion 360 and they've called it Autodesk Fusion. So basically they've just dropped the 360. So absolutely, so going forward, if you contact me regarding Fusion 360, I won't know what you're talking about and I'll presume you got the wrong number. No, only joking. Obviously, it's only a drop of 360, so it's not an actual big deal at all. It's just a very subtle change. The changes in branding have no impact on functionality of the Autodesk Fusion. Changes are primarily cosmetic with updates to visuals such as the app icon, which we can see there with the F. The splash screen, the sign-in screen, and the in-product naming all reflecting the new Autodesk Fusion name. So now that we have highlighted everyone on the rebranding, let's get back into the manufacturing extension. So just before we drive on here, I'm just going to run this little poll question here. So again, I'll just give you a couple of seconds to answer into this one. So what is your current CAM software? That's if you're using CAM at all. So why the manufacturing extension? So today I'm going to be only focusing on the machining element of the manufacturing extension, which is just one of the three elements. If you go back to the previous slide, it's the nesting and fabrication and the additive build, which are the other two elements of it. So I'll be just focusing on machining. So why would you get this extension, especially if you have if you only have a 3-axis machine or single spindle lathe? Without the extension, you have already the ability to create programs that work perfectly fine at the moment. So most people have the impression that the extension is only good if you have multi-axis machining abilities. This is definitely not true. So why the manufacturing extension? So it's going to save time. It increases the quality of your components that are coming off the machines. It reduces scrap, minimizes programming time, minimizes machining time, and in total it lowers costs. In my own experience, whether I was managing a CNC tool room or programming and running machines, these 6 points were always being worked on. Even when we achieved them, we'd still work on them. So when you improve, you just keep improving. So how is the machining extension going to do all of these tasks, or how is it going to help us? How is it going to lower costs and minimize programming and machining times, etc.? So without overwhelming you, this extension has a huge amount in it. It has more efficient toolpath strategies, the ability to cut any geometry, remove error cutting, finish parts with automatic edge detection. I presume nobody's still using needle files and deburring tools anymore. It can reduce toolpath regeneration, hole detection, and so many more options. These will all be used, not all of them, but they will be used, a good shot of these will be used on a daily basis, and that's 100% fact. All of these functions you see on screen are part of the machining element alone. So there is quite a lot in it. I'm only going to be focusing on my favorites. If I bring myself back to my machining days, these are the ones that I think I'd be using every single program. I'd have these would all be used. So yeah, on a daily basis, all of these will be used, and it'll definitely decrease your programming time, decrease machining time, increase quality, etc., etc. So I'm only going to be skimming through my top 5, which again are applicable or are also applicable to 3-axis users. To note, these are very simple to use. They're not one bit complicated. So again, a lot of people see all these new strategies and they're like, geez, another area to learn, and they get a bit flustered and they go, oh, I don't have time to be learning that. These are absolutely simple strategies to use. You can do them in a matter of 5, 6, 7 clicks of the mouse. You're not having to put in a huge amount of information. If you're already a Fusion user, you'll notice how user-friendly the software is, that you can actually create toolpaths very, very quickly, very, very easily with the default settings which Fusion has built in already. So steep and shallow is one of the ones that I always zoom in on. So it came straight out of PowerMill, a super strategy that will reduce programming time massively and increase the quality of your parts. Hole recognition detects all holes in the model, whether it's a standard hole, tapped hole, counterbore, countersink, what else do we have, reamed holes, etc. And it's a nice way to see what type of holes are in a part very quickly. So if you wanted to just scan a part that a customer may have sent in, you can actually use the hole detection to see what type of holes, and maybe you'll notice that there's an M2 or something neatly stuck in the corner of a part, which you didn't realize when you actually took on the job. So again, it's a huge beneficial tool to have hole recognition. Then we've got deburr, again a detection model on creating or which will break all edges using obviously a 45-degree or a spot drill or something. It doesn't some type of an angled tool, but it detects your part and it looks for all the edges. Trimming toolpaths does exactly what it says, but it's a brilliant feature that will be used in every program. And splitting tool, when you have a toolpath that you want to break in two, for the reason as some tools you may have to pull out to have to be sticking out of your collet a lot longer, and you don't want to be using or having deflection or vibration, so you want to cut that one strategy in two. You can do that with splitting the tool or splitting the toolpath. And the last one then, geodesic maybe. I don't know if I'm pronouncing that correctly. Geodesic. It's fresh off the production line. It's a strategy coming for Fusion, and which I'm actually going to go through at a later point. So that's actually only in Fusion, maybe 2 months at this stage. So it's an awesome strategy as well that I wanted to point out. Okay, so let's look at the steep and shallow first. So without the steep and shallow strategy, you would have to spend time applying at least 3 different toolpaths in order to machine a pocket like you see on the screen. This would take a lot of time, lots of editing, lots of manipulation, creating sketches for boundaries in the design environment. Way too messy to be trying to do all of that work without this machining extension or without this strategy. So steep and shallow machines steep areas and shallow areas using a combination of contour passes, the parallel passes and scallop passes. The programmer has the ability to modify what is steep, what is shallow, tool directions, and so much more modifications. So I'm actually going to jump in because I always try to do some bit of a live demo. So I have this part here on our screen. So you can see this part here would be fairly complicated to try to go and machine all of this. We'd have to come in and we'd have to use multiple different types of strategies. As we can see here, we have a huge amount of strategies that comes with your basic Fusion. So you'd end up spending a lot of time trying to get into all of these tiny little areas, get nice directions, nice flows to work all over. So one of the basic operations that we have with Fusion that you can use without the extension is this parallel. So you can see the parallel does a good job of flying over all of this, but you can see it doesn't do a great job on the steeper areas. It doesn't have any direction as well, so you could imagine the finish on this would be fairly crap. We've also got the scallop. Again, scallop does a great job of it. It does a nice job of the steep and the shallow area. But again, you can see the toolpath, it's not going to look pretty when it's finished. It's just, it doesn't go with the flow of the fillets, I suppose. And then we have contour. So again, the contour does nice. It kind of follows the flow of the fillets, but then it doesn't do a great job anywhere else. So again, you would end up having to probably have a massive combination of the 3 of these strategies in order to get in here and do a really neat job of this little pocket area. While the steep and shallow, it does a really, really good job. And this was like a couple of clicks. Like I just literally selected, actually I think I did a right click on the parallel and I create derived operation and I did a steep and shallow, and all I did is decreased the step over, because I think the step over for all of these was maybe 1 mil or something. So I've decreased to 0.2. So again, it mimicked the parallel and it just applied the steep and shallow, but we can see that when the steep and shallow is shown up, that it is flowing around with the fillets. It's actually doing a nice job on the flat surface and on the steeper areas as well. So within that strategy as well, we can set it that we can select faces to avoid. So we don't want to machine all of this because that would be a waste of time with the ball nose. So we can select what to avoid, or we can select what to machine. So you can see we can just tell it to machine the corners here and the flat surface here. So you can see it is kind of sharp with the corners. We can add on the smoothing, so you can see the difference between the sharp corners and the smoothing, and we can remove cusps as well. So you can do all of this within the steep and shallow also. So, and you can set, as I said to you a while ago, if I actually go in and edit one of these, we can see the manipulation we can mess around with inside here, where we can tell it what slope from which areas we want to have a scallop and which we want to be parallel, etc. Huge amount of manipulation inside in this strategy to be able to do this. But the main point I want to point out is you're cutting down your time basically in 3, probably way more than 3 actually, because the amount of time you'd spend tweaking these 3 strategies in order to just do this, you'd probably save easily for this part, I'd imagine, an hour or an hour and a half, if not 2 hours, because yeah, it would be very difficult to get in there and machine all of that. It also allows us the ability to do undercuts. So you can see there's an undercut here. Again, if you have a 3-axis machine and you don't want to be spinning your part up for another operation, we can do the undercut here. So if I just run the simulation, I think I'm using a lollipop tool. You can run that undercut. So that is the undercut. So I like to just do little simulations from time to time. It's a bit dodgy when I'm doing it live because it can end up lagging a bit. So if you see it lagging, it's because I'm running this on the live. But yeah, I like to do the simulations, and I know my manager loves when I do a simulation also. So that's a little bit about the steep and shallow. So I'm just gonna 1 second. Okay, so I'm just going to jump back to my PowerPoint. So that's steep and shallow. So again, yeah, it's a massive, that one strategy alone is worth getting the extension for this. And I've had customers who have said that also, that one strategy has been a huge time saver for them. So the whole recognition, so the next, the whole recognition automates the process to create whole machining operations. The model is analyzed for cylinders, and those cylinders are assigned to an action. And you can override the selection for different types of actions. The actions will be a combination of spot drilling, counterboring, boring, tapping, or reaming. Sorry. So if we just get a little bit of a better look at this. So you can see here that that part, by me just selecting the whole recognition, I get this menu appear. And you can see straight away that it pulls out all of this. And this is what I was saying a while ago about even if you weren't you just wanted to look at a part, you can actually see what type of holes are on this. So you can see it has all of these tooling already. So if I just hit OK on that, we'd end up producing all of this. And again, what's that, like 10 seconds work, as opposed to if I was to write all of these without the extension one by one, couple of hours again, you'd be messing around here trying to do all of this. So what I'm going to do, because it's nice to just, again, some people don't believe me when I say this. So we have a part here, which is the one I had in the PowerPoint. Again, we're running this live. This isn't a video written, so I may make a mistake or I may lag. So we have a setup done here already. So I'm just going to click on the whole recognition. My dialog box appears. You can see it's telling me which holes are which. And if I want it, I can go into my options and I can select multi-axis machining, and I go back, and now it's even giving me all the other ones. And if I just press OK, there we are. Everything is done. So again, that was it's a huge timer. Again, it's a no-brainer to have that tool as part of your package. So again, going to jump into the next one. So that's the whole recognition. So I've only like 5 of these to go through, so don't worry, I'm not going to keep you for hours here. I am trying to keep it to within the 45 minutes, but I may finish up early. So the deburring strategy, nobody likes deburring parts. Deburring parts by hand can be very inconsistent, especially when you're using needle files and deburring tools, etc. Again, I'm just going back to my years ago when I used to be machining. That's what we used to always do, loads of needle files, loads of little deburring tools, and we'd have 10 parts and they'd all look different. Improving the quality and reducing time spent deburring is always a win-win situation. It looks more professional when the customer receives his batch quantity and they're all identical. The deburring strategy is a finishing operation used to deburr external corners that are sharp around it. The deburring improves the look of the part and its fit. It also reduces safety hazards when handling the part because sharp edges get deburred. My missus would vouch for that. I used to come home with plasters all over my hands from tiny little nicks. So if we just have a wee look at this, so you can see here that what I'm showing is it looks for edges. So it takes into account the size of your tool and the shaft, and it allows clearance, so you don't have to worry about the tools crashing into walls or areas of the part, leaving bad finishes or burns, etc. So we have a shaft clearance of 1 mil here, which is quite big, and you can see, here there's the 1 mil clearance. So if it was me, I'd be pumping that down to probably 0.2 to get right in there and as close as possible to that. You can also adjust the width, so you're using different parts of the chamfering tool as well, so you could actually chamfer all of this all in, or you get the whole lot of it if you messed around with them settings. Okay, so we just come back out, and again, this is you can apply this for 3-axis, 4-axis, or 5-axis machine. So again, if you were running this on a 5-axis machine, it'll pick up all the parts. Not too sure if I have a demo for that one. Let me have a look. No, I don't. Sorry, so I didn't do a demo on that one because it's very basic to do. And again, it's just clicking on the button, very much like the whole recognition. It'll pick up every single edge, and you can deselect ones you don't want to touch, and you can reselect ones you do want to touch. Actually, you won't, because it picks up every single edge. So you can deselect the ones you don't want to touch. Okay. So trimming and splitting tool parts. So my data set here is not very pretty looking. It's just a cheese block basically on the bed, and I want to just skim the top of it. If I was to do that, obviously I need clamps to hold it onto the table. So this function is hugely important and so handy if I didn't have to be messing around with sketches and the design environment, using them as boundaries to avoid, again, loads of unnecessary work. The toolpath allows me to get rid of areas where the cutter may be cutting air at times, but it also allows me to not touch areas that I need to keep the tools away from. So let's jump in here and have a look at this. So there we have our toolpath. This is just a very simple parallel. If I was to add my clamps onto this on the table, now I'm going to end up smashing my cutters here. So do this very, very easily. I can just spin this up like this, and I'm oversizing this, and I'm going to OK that, and I'm going to do the same over here. Again, not very nice the way I've done that, but you can see what I've done there. I've removed the tool paths from them two areas in order for me not to hit them clamps. I can even go a step forward, or a step further, sorry, because I'm going to have to come back and machine these. So when I have this done, I'll probably end up moving the clamp over to here and this clamp over to here, and I need to finish off this area. So what I should have done is, if I go back in and edit, and you can see it creates this in the design history, I want to go and say boat and press OK. And I want to do the same over here. I'm going to say boat. There we go. So now I actually have that also, and I've got that as well. So now you can see I can go back in and finish these, and I have my different toolpaths available. So I have 3 different toolpaths, 3 different tools, or 3 same tool, whatever you want to do. But again, massive time saver to be able to do that, and you can cut whatever you want. You can cut different shapes, you can you can use the boundary or sketches or surfaces or planes to do your trimming and cutting as well. So if I just jump over here, so the next one that I want to look at, what did I do there? I think I clicked something too much. Sorry, I have to go back. So again, another nice thing of splitting the tool is, again, if I have a part like this, we can see it's going to machine all of this. I'm actually using the steep and shallow again, and you can see steep and shallow is pretty impressive. But I want to, my tool may not reach down in here, so I don't want to have my cutter sticking out too far. So I split the tool in two. So I cut this piece out, and I left that be, and then I'm going to swap tools, and I'm going to go in with a smaller length tool in order to be able to reach inside there. Or I can change the tool completely and go to a smaller size, like a 6mm instead of an 8mm. But you can see over here now I've got two different tool paths, both the steep and shallow, but it's taken both into account. Again, huge amount of manipulation, step overlap, etc. And do all of that within that. So okay, back to PowerPoint, and the last one we're going to look at here is the Geodesk. So the Geodesk or geodesic strategy. Apologies. So this is a new feature in Fusion, as I mentioned earlier. The strategy performs a finishing operation to machine free-form surfaces and difficult undercuts. This toolpath consists of multiple passes arranged in patterns using different types of offsets. Using this strategy, you can achieve smoother toolpaths with a higher quality of surface. So I'm going to jump in here, and we're going to give this guy a go as well. So you can see here's a completely bizarre looking part with loads of different curves and surfaces on this. So this is actually a free form part which consists of multiple surfaces. So it's something that Fusion wasn't able to do at one point. When you were trying to do surfaces, you had to use a different strategy, which would have probably been a blend. Or there's another one, I can't think of it right now. So just the blend was a good one for doing surfacing, but it was very left, right, or in, out type of a movement. Where the Geodesk, we can cover the whole part, and we can see here that it's actually running over the hole. It's not actually going into the hole. So the toolpath is going straight over the hole, and we can do this as well by, we can just dodge the hole if we think, yeah, we're going to be cutting a lot of air around here. We don't want to be doing that. We can actually dodge the holes as well, and it takes that into account. So you can see the way the strategy is cutting here. It looks similar enough to a scallop, but it's on an actual curved surface. But you can see, yeah, it could get, like your finishes might be a little bit inconsistent, I suppose. So you can actually go into the geodesic and change what type of finishes. So we can do a circular motion. So you can see here, a little bit prettier, but up here, we can see it has a different type of it's moving a different angle. We can actually follow the curve. So what I've done for the next one is I've followed this curve, and it's taken that into account. So now it's actually doing a lovely, lovely flow right around this part. And you can imagine the finish on this guy would be nice looking. And then again, we can go into the pockets. We can select different surfaces, different fillets to go in there and machine out. And again, changing the way that we machine it. I think if I go in, I hate going into editing things on a live webinar because it sometimes won't allow me. So if I go curve with selection and I want to go with this, press OK. Hopefully this won't take too long to update. And we can see now it's actually flowing with the curve on this. And then the last one then was, I can't remember what I was doing there. I think I was still messing around with trialing on this guy here. So that is a little bit about the geodesic toolpath. So again, that is after being added into Fusion, into the extension, only in the last month. But it's definitely, it's a I was actually presented last year from a customer. They gave us a part, and I couldn't actually get the machines because it had 4 surfaces, and they kept doing one surface and then jumping up and then going into the second surface. This geodesic would have solved that issue. So I must go back and reach out to that guy again. Okay, so I have another poll question for you, which is the last of the poll questions. I'm just going to launch this guy here. So what manufacturing capabilities do you currently have? So yeah, that's it all from me, guys. Thanks a million for everyone joining again, and yeah, feel free to throw any emails our way if you have any other further questions or need some guidance or help or demos or further demos. Awesome. Thanks a million, everyone. Cheers. Bye.